Good afternoon, everybody. Thanks for joining us. Hopefully everything's going well and you guys are having a great time at the conference and learning a lot. They're here to present. So you guys, as you go through, you can see in the chat window, there's a chat where a couple people are chatting now. And there's also a Q&A, which is the questions and answers. So Jim Lemke is going to monitor that for us. And then as questions come in, he'll try to answer those questions inside there. And we kind of go from there. Daniel, next slide. So just to introduce ourselves, we're going to do it's not CAM-plicated, trying to thing there. So we're going to go through and see what we can actually make life easier in the machine shop. So by reducing manufacturing time, by using the tools we actually have. So my name is Tim Fulton. With me here is Daniel Lyon, and we'll be doing the presentation. So as you guys know, we do several products here at Hawk Ridge. The three we're going to focus on is CAMWORKS, Eureka, and Predator out of this group. So along with us today, we had a couple of sponsors. We have CAMWORKS and Predator. So they have their own booth. A lot of you I've seen already went over and visited them. They're in the expo area, and they can answer more questions. We're going to keep this kind of at a higher level based off what we designed to show for you to keep things moving faster inside the actual shop. So if you have time, please go over and see them after you're finished with us, or tomorrow. They'll be there for all 3 days. Daniel?
Yep. Hey guys. So just to, again to recap on the layout with this new format here, you'll see there's a chat window. That's where a few of you guys are all chatting right away. There's also a Q&A question area as well. So if there is a valid question that you guys want to ask rather than doing your chatter, put that in the Q&A so it'll stand out to us so we know we can address that, and Jim will answer those for us here. So, and don't forget there's a contest going on, so feel free to visit the different vendors, interact with them. Obviously with the whole situation with COVID, it's a nice format online that we're doing to make things easy and still have our conference like usual. So the agenda for today is we're going to look at machining part of this hood hinge assembly here. We've got this hood hinge that we've got inside of our SOLIDWORKS. We've been through and we've kind of tested out the motion of it, seeing if it works correctly as we kind of expect it to work, and kind of articulate the way we would need it to move. So we've got correct hood clearances and things like that. And we're going to actually machine this back plate here that mounts to the vehicle. Now, we're going to go through a few different areas of streamlining the programming and running the job, and looking at where we can save time in both of those areas. If we have time right at the very end, there'll be some question and answers right here. If you obviously have questions, you can answer them or ask them during that anytime during the presentation at that Q&A section. But if there is time at the end, we'll have a little bit of time to address any questions that have come up there as well. So what are we going to look at now? Tim's going to walk you through basically using feature recognition, controlling default strategies. How do you sort operations quickly so you can kind of minimize tool changes and structure your programs a little quicker? How can you resequence your tools? What are assembly features? And how do you make multiple parts in one program? And then we're going to look at running the job side of it. So how do you optimize cycle times using a new product called Eureka Kronos? How do you reduce the program size? What methods and steps you can take to do that? How do you verify your actual toolpath is correct offline without having to tie up the actual CNC? Looking at actually programming with some variables. Looking at also how do you load programs from where you're working to the CNC, and how you can get the actual programs onto the control. And then looking at machine data collection and what we can do with that. So I'm going to hand it over to Tim, and he's going to take it from here.
Okay. We're actually going to turn our videos off to save on bandwidth while we're running these big models here for you guys live.
So you should have share screen. Yep.
Perfect. All right, good. Thanks for that check. So inside it, we're going to set up, we set up in an assembly mode. So everything I'm going to show today can be ran either in SOLIDWORKS CAM or CAMWORKS. So whichever you guys are running, you'll be capable of doing this. And you can get going, inside your own environment there. So I chose to run mine in CAMWORKS today, just to kind of show some more stuff as well. So on the CW tab, this is called the feature tab, right? So we have a SOLIDWORKS feature tab and we have a CAM feature tab. So first thing you want to do is you want to kind of choose your machine. So you can go through and you select that. Today we're going to run it on a Haas VF3. So we're just going to select that machine and hit OK. Then we have a tool crib. We're going to choose that next. And the tool crib can be either machine specific, it can be part specific, it can just be a random bunch of tools in a toolbox if you want. So this is really set up the way you want to do and way you want to dial it in. And what happens is it analyzes the tool crib and applies these tools to the actual features. Post processors, we do a lot of custom posts inside here. We can go through and set those up for you guys however you want. We also have a bunch of free ones on our website. So if you're struggling, can't find what you're looking for, this is the place you'd actually do that on our website to do that and download those. And then as you get into our more custom posts and not the free ones that come with the software, you will see you have more options. So, output setup names, we can modify this however you want, who programmed it, what time they programmed it, where it came from. Right, so it makes it trackability, and it also allows you to set custom stuff that might be outside the CAM system. We can run it on the posting side of things as well. So choose that. I'm going to set the stock manager next. So this is where you kind of get into some of the new features that are inside SOLIDWORKS CAM and CAMWORKS. So this is the basic bounding box we've always had. Down here, you have a predefined bounding box. I just have the default set as 1 right here because you can load whatever you want. And I didn't want to load a bunch of them and all of a sudden you guys open up your computer and it's not there. So I wanted to go through and show that with kind of go through here, right? So you can set your default, set your length, set your width. So if you use a lot of 2x2, 1x3, whatever the case may be, you can actually set that information. Another one of my favorite ones here is a cylindrical circle, right? You used to always have to take and set up a circle in here with a sketch, right? Put the sketch in, then you had to choose as your circle. Now it just kind of defines that, and you can modify this however you want, bigger, smaller, whatever the case may be. So for this one, I'm going to run this. A trick here, a lot of people will go through and put different things in. This button is live. So if I put 0.1 in there and I pick here, you can see it actually puts it on both sides as I'm doing this. So the game today is I'm going to show you kind of what's new. I'm going to show you a few tips and tricks along the way as well. Hit OK there. Next thing, my stock coordinate. I can choose just user defined. I can pick anywhere where these dots are. I can use a SOLIDWORKS coordinate, anything I want to do to set any information up inside this area as well. So I hit OK at that point. Now the idea with the whole feature recognition is just extract machinable features. So if you just kind of go across, this one's lit up, this one's grayed out, right? As I push on this one, you will now see once it starts going through the features, it's analyzing the pockets, the holes, the bosses. It's looking at the SOLIDWORKS feature tree and it's trying to figure out if I use the hole wizard to tap any holes. So it's putting all that information in right now. And you can see I get a face feature, right? I get a parameter feature. One of the things I want to point out here is I get this default, which is rough, and finish, right? And in the past, you always had to right click and you had to go through and then you had to go to the parameter and you had to come over here and you had to pick the parameter you wanted to change it to rough and finish. So everybody want to do a shift, hold, whatever the case may be to get through that. So what you can do now is you can just come up here to the default feature strategies and pick on this icon. And then as you can go through and see how everything's all set up. Everything that's in bold is what's being used over here on this side. So if I take my circular pattern, I pick it, I go to rough and finish. I take this one that's bold, rough and finish, and I can do this one as well. You can set these as your defaults ahead of time. I wanted to show you backwards in case you forgot, then you'd be able to just very quickly go through and change those. But you can apply these and you can save these to the database however you want up inside here. I'm going to hit apply. Everything changes automatically. So definitely a time saver there. Now what I'm going to do is I'm going to pick the next icon. The other two are still grayed out here, right? I'm going to generate an operation plan. So now what it's doing, it's in the database and it's going, okay, based off a irregular pocket, what size tools will fit inside here and what can I apply? So it's analyzing the size of the pockets. It's also analyzing the tool crib and applying those tools. So you can see it's got a rough and a contour, a rough and a contour, right? The reason it does that is because back on this page over here, it says irregular pocket, rough and finish, irregular pocket 2, rough and finish. So you can drag and drop whatever you want in your certain order here. You can also pick on the setup. And then by picking on the setup, you pick the sort operations. I just grabbed the sort button here. And if I want to do the face first, maybe the rough second, and then the contour third, right? Leave the rest as the defaults. I hit apply. And you can see my screen now changes and it puts it inside there. So now it's going to save all those tool changes. It's going to put the one tool in and do all the work. Next tool in, do all the work. I'm going to hit OK now. And at this point, I can actually set up and I can generate my toolpath. If you notice, it's the next one that's become available now. So I'm now going to generate my toolpath, and then there's my toolpath now to run that model. These toolpaths are defaults out of the technology database. You can customize the technology database however you want. If you like just doing it on the fly, like every other CAM system, you're more than welcome to do that. I can double click here. And then I can choose what I want to do, right? I can change the tool. I can go to feed rates. I can go to operations. Everything becomes available. I can uncheck check marks. And now I have information down inside there. My roughing, pocket in, pocket out, zigzag, spiral. It's all available just like anything else. So how I got there, I just double clicked on here and then I was able to make those changes. So now if I wanted to simulate the toolpath, that is just the next button here. I pick on that and it launches the simulator. So you have different options. I can see the part in here. I can go in and maybe I don't want to see the display. I can turn those on and off. So you have lots of options when you're actually running the parts inside the environment here. So I can take that and I can just hit the play button and it just starts running my information and doing that inside there. I'm gonna hit the checkbox now. Now, one thing I want to do, we've got this new probing routine on this new machine we just purchased. So I want to be able to probe the part while I'm running it. So if I right click here, and I can do it anywhere, I can also right click at the bottom. It doesn't matter where I want to do it at, right? And I'm going to put in a probing operation. So I'm going to pick that. I have my tool and I can select other tools out of a tool crib. You can get different sizes, whatever you guys want to do. Hit the checkbox there. And now what it's going to do is going to open up the probing window itself. So one thing that I've been told is you always have to put in an actual raw stock out of the SOLIDWORKS environment to be able to probe the corner. So there's a trick to that. You do not have to do that. So inside here, the X and Y location, you can choose right here and it'll just select the stock. And what it does, it just puts in the plane on the farthest outside part with that 100 thou that I put on there. So I can do the same down here. I pick on that, right? And now I'm going to probe the center, but I don't want to probe the center. I just want to probe the left corner up here, right? So just like any CNC machine, I got the X positive, I got the X negative. So I just take the X negative or positive here. I hit the delete and now it just probes the one side. I can do the same here, Y negative. Pick that, hit delete. And then I can move these wherever I want back and forth. So if I want to do the X, I just do negative, 4 inches. And then it just comes back to the 4 inches of wherever it's going to be at. So very simple to do. And you notice it's set to X and Y right here. If I hit the OK button, now I can go through, right click, I can insert another probing operation. And then what I want to do on this one, hit the checkbox here. And all I want to do is I want to find the Z. So I just pick on the top, same game, right? Pick on the top here, and now it probes the top of the part. And I can hit OK. One more quick trick before I turn this program back over to Daniel. As you can see, I have the probing all set up inside here. I can sort operations or sort tooling, sorry. Sometimes people think you have to go in here and you physically have to choose the tool. You have to go to the tool station here and you have to change it to tool 1, tool 2, tool 3, whatever. If your machine is set up and these tools are in the right position where they're supposed to be, by all means, don't do this, right? But if you're just loading the carousel or loading whatever the tool changer is, the magazine, you can go through and get that all set up by just right-clicking on there. You can then go through and sort and reorder the tools. And then what on a reorder tool? So if all of a sudden a job comes in, I can use tool 10 and up, I can use 5 and up. I'm just going to start at 1. And now I have tool 1 set up inside here with my face mill, as you can see that. Problem is my probe's at the bottom, right? So I still want to probe first. I'm just going to drag it, kicking and screaming up here to the top. And now my probing is now set up. And now this program is ready to be programmed and ran at the machine.
So, hey Tim, that's pretty much a good job we're doing that probing routines. I think we just took an order for 500 of these things, so we're going to need to take out every little bit of time we possibly can. So that's
I
really going to
thought we
help
were
the setup
doing.
guys.
I thought we were doing one.
No. 500 apparently. Sales guys going nuts apparently.
Well, good for
You
him.
pass it over. You want to pass it over to me, and we'll see if we can take some time out of this.
Yep. Here it
Perfect.
comes.
So everyone should be able to see my screen now. So we've got
I can see it.
Tim. Perfect. So we've got Tim's program loaded up in a tool called Eureka Kronos. Now this is a new product. A few of you might be familiar with VoluMill. VoluMill is designed to obviously optimize feed rates and remove a lot of material at one time. What we're going to do here is, this is essentially taking our program that's over here on the right that we just produced. We're going to play that through here. And this is, Eureka is a tool normally built for doing machine simulation. But the nice thing what they did with Kronos is they actually took the machine simulation, took the existing path that you've got, and actually use this to check the actual tool path, to check to see if, hey, you're actually machining correctly, but also to make sure that you can actually optimize your cycle times. Now, obviously, I mentioned VoluMill before. VoluMill is changing the tool path itself to be a different path itself based on the volume of material, so it's trying to optimize that material. What Kronos is doing in here is analyzing based off of the actual G code that you feed it and trying to look at where we can save time by optimizing the volume of material that's being removed. Essentially the same thing that VoluMill is doing, but on every single path that we have. So you can see on the left-hand side down at the bottom there in orange, that was our cycle time before. So at the normal feed rates and everything else for running this part, we've got a 41-minute cycle time. Now we can save 22% of that time by trying to optimize the feed rates. And I'm just going to go in and explain what it's kind of doing. So you saw Tim put in a face mill operation at the very first tool. Tim's tool one was his face mill. So you can see in the vice setup right here that we were doing a zig and then a zag and then a zig move coming across here. That corresponds to these three chunks right here. Now the orange section here is before the material, before the actual optimization. The green is after the optimization. So you can see at this point in time, the bottom section is the volume of material being removed per minute, basically. So we do our zig move and then we do our zag move and then our zig move, you'll see when you program these, when you lock the feed rates in, they're cutting at that feed rate throughout the entire cut. Basically, you might have a lead-in feed rate that's slower or higher or whatever you want to do, but as soon as you're in the cut, you're usually at a continual feed rate until the very end. Now, the problem with that is we go, as soon as we come off the zig move and we're transitioning back to the zag move, we are essentially cutting air. So what happens at this point is our volume of material drops. But you'll see the orange line here. This orange line is our feed rate. So the orange line is the original feed rate in the program. You'll see that maintained its feed rate all the way through that pass. Now what Kronos is doing is going, okay, well, when you're air cutting right here, I'm going to optimize the feed rates by cranking up on them. So it's going to use these numbers right here. We're cutting on a horse, so we're going to set it to the horse default. So 650, I think, is our maximum cut speed in a feed move. So if I hit apply, you'll see we'll recalculate this now based on those new values. Now we're saving 15%, but just in that one face mill operation. You tally that up across a number of operations, you essentially get a pretty significant time saving overall. So we're looking at volume of material being taken out and actually changing the feed rates to optimize that material removal. Now, you might also think of the situation, well, what happens if I'm not air cutting? What happens if I'm taking too much material? Or maybe I'm spiking the volume of material on entry, or I'm going through a large amount of material at any one time. You can see that on, say, tool 3 or tool 4, we actually go in here and you can see that kind of close to the entry point right here. And you'll see if you hover over the move itself, it tells you, hey, this is line 858. And I could obviously go back and look at where that is in the simulation, check it out. But that is spiking the actual volume of material. Now that could be right where you break a tool. So this can help you save tool life by obviously reducing the feed rates where you're actually not taking a huge amount of material. So you're actually slowing it down so that you're actually taking less of a volume. And that's what it's doing here in the green. It's actually slowing it down rather than speeding it up. And trying to harmonize the actual feed rates to balance everything out. And that's what Eureka Kronos is doing. Now, this is a standalone package. You can use it on any software, basically, any input. As long as you've got an STL file, the tools that you want to use and the program, essentially you can load it into Kronos and put it in here. Now, what this Save Optimized program does is it actually adjusts it, writes the changes, and gives me a report based on what my changes were. So you'll see now, this right here is our optimized program. You'll see once we get into the face mill moves, you'll see those feed rates changing as it's going in and out of the material. So it's actually optimizing that cycle time down. Now, maybe I don't think one part at a time is going to cut it if we're doing 500 of these, though. Tim, what do you think?
No.
Take a little bit more time.
Yeah, you want me
to
reprogram it? Change this? Yep.
Yeah. Let's go ahead and reprogram it for doing the 3 parts instead of just 1.
Did you say reprogram?
Yeah. Is that not what you have to do?
No. Dude, we're in SOLIDWORKS CAM and CAMWORKS. There's no reprogramming. Sit back and watch this. Just going to go insert, do a pattern, linear pattern, right? What direction do I want to go? And this is SOLIDWORKS stuff, right? So I'm going to pick on this edge right here, and now I have my arrow going the right direction I want to go. Inside here, I'm just going to go to 12 inches. And I'm going to tell it how many vices do I want. I want to add 3 total. Pick on that, and I'm just going to window select and grab those. Oh, I better pick down here first. Pick on that. And now I have the 3 parts going across there. So now if I hit OK, you can see I now have 3 parts, right? Now we have the whole parent-child trick, right? So inside here, I'm going to go to Part Manager. I'm going to manage the parts. I'm just going to tell it that there's 2 more on the table. I'm going to select those. I'm going to hit OK. And then there is all your programming. So there's no reprogramming. There's just, we went from 1 part to production that fast. So one thing I did think about, Daniel, is, when we're out saw cutting, I don't know if I want the saw person to go through and cut 3 different pieces. What do you think about just putting 1 piece in here?
I think that's a good idea. Why have we got a CNC if we're not going to use it? And we're going to have the guy cutting pieces manually by hand.
There you go. That's what I was thinking. So I'm going to go to the stock manager inside here. And then there's an option down here in the very bottom, right? I can choose all 3 of these. I'm just going to hold my shift key and grab these. I'm now going to combine the stock, change my instance here so it all becomes 1. And now I have 1 piece of stock to do the whole part. So at that point, I can also change how I want to do things, right? I got my X here. I can set this to 0.05 on both sides this time. I'm going to try to save a little bit of material. This is still going to be the same because this is the raw material. And the Z will be raw material as well. So that will be the same. Hit the checkbox. And I get this new warning, right? This is in 2021. It says, hey, based off what you've done, you've moved the coordinate. So by moving the coordinate, there's a bunch of things that you need to change inside here as well. So I'm just going to hit the yes button. It's going to readjust my coordinate, and it's going to recalculate all my toolpath. And now my new toolpath is based off that coordinate. One thing inside here is there's a face tool, right? A face tool, a face tool, and a face tool. So back in the past, you always had to kind of draw a sketch, and then you had to go inside here and you had to suppress the information that's set up. So what you can do is go up here in the instances and set this information. Let me go back to the right tree here. So I go back up in here, my feature tree, right? And then here's my face feature to do that. And down here is all the 3 different features. So you used to right click and suppress, and then you could do what you wanted to do from there. A great feature, right click, assembly feature. So if you make it an assembly feature, it now takes that, and you've noticed down here, it turns it all to 1. So if you look inside here, when I double click on this, you will see my stock is now all 1 piece. My end condition remains the same. It's the 0.1 I had in it for the stock. I hit the checkbox, and now over here on the operation tree, you can see my face feature makes 1 pass across the whole part. So pretty simple to go from standard into real production real quickly. So I'm going to turn this back over to you so you can show the next part.
Perfect. Yeah, I love that option. I used to keep doing it the old way of doing it, individual face mill on each piece, and it was getting kind of tedious, right? So cheers for
Yep.
that. We'll drop it in the vault. Yeah, everyone should be able to see my screen now. And what we're going to do here is look at where we can maybe save some cycle time. Now, if we've got 3 pieces on the table, obviously we're going to have 3 times the code. Now, when you've got large programs, these are relatively small, but if you've got a large program, the last thing you want is having triple the code for doing 3 of these pieces. So what we're going to turn on in our CAMWORKS is the ability to do sub-programs. Some people call them subroutines. If you're using M97, that's a general term, M97P, and then a subprogram number or a subroutine number. Or if your post is set up differently, it would be an M98, and it would actually create a separate program rather than going to a line number. Both similar sort of deal, but you can now change these and control them whether they're based on operations. I think that was actually a 2020 feature, but it's really nice way of doing it. Now we're going to do this for all operations. So it's going to basically run the first one and then loop through it 2 extra times to do the second 2. So rather than outputting 3 times the code, we're outputting 1 program and then looping through it a number of times. So we go over here, we generate our toolpath, make sure that's all up to date. And then we're going to actually just check this out on in the machine simulator. So I've got this set up to run a machine simulator. We're going to actually take our G code in this case, output our code to machine simulation, and backplot it. Now, a lot of people will often take the code that they're running, stick it on the real CNC, tie that machine up from actually doing production work. And that's the last thing we want to do. That's an expensive machine, basically sat there, not cutting parts, testing out code. Now, if you've got time to do that, fair enough, but we don't. We got 500 of these to make. So the last thing we want to be doing is tying that machine up, doing testing. So we've launched that straight from CAMWORKS straight into Eureka, or CAMWORKS Virtual Machine, if you're familiar with that, essentially the same product. Now what it's going to do is transfer all of our vices. You can see them just jumping in there now, transferring all of our fixtures. This is because we're in an assembly mode in SOLIDWORKS. We've got our program on the left, and you can see the way that this kind of works over here is it loops through the program by going and hitting this M97. So we've contacted support. We've had our post adjusted to support M97 routines instead of M98 routines. So now it's just going to loop down to the bottom of the program down here and loop through to this N number every time. So you'll see the face mill doesn't do that because we've got 1 assembly feature, and that's what that assembly feature is doing. It's just making it occur once rather than for every instance of the part. But we still need to set our offsets in here, basically. So we need to control this. What I'm going to do in here is you'll see the G52 command is kind of a standard FNUC command, but what it does is it kind of does like an incremental shift of the work offset. Now, you have to increment it to say X12, which is our next vice, and then X24. But before you go X12 and then X12 again, because that would be technically where 24 is, you often have to reset it back to 0 and then reset it back to 24 again, which confuses the operator. So I'm just going to replace all these, and I'm just replacing this right in the code. And I'm going to switch it with G56. So that's going to be our third vice because X24. We're just going to replace all those instances right here. Obviously, I've been through this. I want to check to make sure that the instances and the work offsets are correct. But we want to basically go through and replace all those instances of X12 as well. So those in here are going to be our second vice, which is going to be G55. Replace all those. So those are all replaced. And then we're just left with the X0, Y01, which is our G54 original one. So we've got our G54, replace all of those. So I'm making changes to my program, but doing it virtually. Now, I don't know if you've seen any issues with that, Tim, doing it on the actual machine, and anything else like that you've seen?
You know, the real hardest part is when I see the programmers or the setup guys doing that, right? It ties up a machine for a couple hours minimum going through and making the changes. So, and I'm not a big person of that, right? I'd rather just get it straight out of the CAM system. But I do understand that there's times that things need to be modified, make it easier, right? You know, you run different shifts, everybody communicates. So I really like this better. because man, all you do is hit one decimal point wrong, and then all of a sudden you're burying that tool into the vise or into the table, right? So at least here it's done virtually.
Yeah, at least we're testing it in a safe manner. We're not risking someone's life instead of the controller, and you accidentally set a surface feed a minute value to 0 and send a boring head or something up to some ludicrous feed rate. So
that never
in here,
happens. You're talking about.
Yeah, right. So what we're going to do in here, obviously we've got one piece of stock in here. We're looping through the code, right? So we've only got one program, but we need our extra offsets in here. We've only got one at the minute. I can go and set that up over here. We can kind of just play it, and you'll see it's probably just going to go to the vise on the table. There we go. That's the sort of situation that some of us might be familiar with. Hey, Tim. We got our part burying itself through the table because I've not set my work offset correctly, right? I come up here, I hit add. Now I can actually go and pick the vertex on the stock itself. So I'm going to go and just set that corner as my work offset. It registers all the values over here. So I can reset that now. And obviously it's going to go and start cutting one of those and facing, if I can zoom out just a little bit, facing that entire piece of stock and running through that program. But like I say, we need to kind of separate this into 3 separate pieces of stock. So using some variables and some programming and macro programming, I've actually got a bunch of programs stored in the controller. We do this quite frequently. So I've actually got a macro that we've written using variables that actually goes and automatically does a slot cut depending on a bunch of parameters. So you say these are arguments. These arguments right here allow us to kind of control how that macro. So it's like a CAN cycle essentially for drilling. But what we're using is a G65P number with a sub program. It feeds those arguments to the program itself. So now what we can do is actually just paste those into our program right here. And I want one at, say, 24 inches. And basically now it's going to go through. We're going to actually stop it at this location. So this is also, if you're familiar with probing, how the probes work. It goes G65P and then calls your 9000 or your tool setter program and things like that, and gives it a bunch of parameters to go check, like bore size and all the rest of it. We're in this case just going to use it for going in and actually creating slot cuts on our particular part. Now we're going to just play through that. It does a tool change. It does one, runs the other one, and then pauses. So now I can actually come back in, hit initial work offsets again. I can add my other 2 in here and just start going, okay, well, I want to pick the vertex here. Go and select a piece of geometry right there for G55. And then we want to go pick the vertex over here for G56. I might want to check the tool length there. It's a little bit close, but we'll call it good for now. So we've just got the part set. We've got our work offsets set. We've got our work offsets adjusted in our program. But what else can we do? We need to run 500 of these. Now we can run things like variables. So variables, if you're talking Fanuc or Siemens or Akuma or whatever type of controller you're using, there's each a slightly different format, but usually in your program manual, you've got details of kind of the formats you use. Now, Fanuc uses pound variables, so I'm just going to create a pound variable called 500. And then I'm going to say that is going to be equal to 0. Now, this is best just to see, basically to make sure that everyone understands it. You want clarity amongst everybody so that they see exactly what's going on. So I'm going to set this part counter to 0. Then we're going to set another variable, and we're going to say this is the batch size. So this 500 that we're going to make them in batches of 27. So we're going to say pound 501 is equal to 27. But we've got 3 parts being machined each cycle. So we've got parts per cycle. And this is all stuff that you might be trying to type on the control, but we're doing it virtually here. Basically, we're going to create another one that's called pound 502 equals 3. So we're making 3 parts per cycle in this case. Now, what we're going to do is get it to loop through this program just by making changes so that we get our 27 basically, and then all of a sudden we've got our batch finished. So rather than having to run this several times, 7 or 9 times or whatever it is, we're going to go through here and loop it essentially. So what we do is right towards the end of the program, right where we get to our M30 down here, we're going to say, okay, well, after this program is run, pound 500, which is our parts counter, is now equal to £500, which is what it used to be, but plus the number of parts per cycle, which is £502. So 3 parts, it's going to add 3 parts every time it loops through this program. And then we can add if statements as well. So your controls understand some if statements as well. So we can write if £500 is less than or equal to, so LE less than or equal to £501, which is our 27 parts, go to 1, which goes to line number 1, which is N1. Now again, we've had our program adjusted so that we've got our sequence numbers set by operation. So our sequence number is right here. I'm actually just going to move that up and make some edits to it up here. So what we need to do above it is we need to go and say, okay, well, as soon as it hits this top section of the program again, we need to have the operator know that it's going to stop. So we're going to stop the machine, reload new stocks, right? So we're going to make some changes, get our new stocks loaded up together, get them set. But we also might want to run in a little check as well. You can also use things like M98P programs. So we've got another program over here that allows us to go and run a tool check. So what we've got in here is another program that, again, we could load on the control. It just sits on that control. But this tells us in here, we've just created new variables in the 600 range for each tool. So I've got tool 1 to tool 20 in my carousel. I'm saying how many parts that I can produce with that particular tool. So you'll see tool 4 is equal to 3. So after this one session, it should loop and hit me. And then we're telling it to do, hey, go down here, stick a big old warning, which is £3000 on your FNUC controls. Stick a big old warning on the screen to say, hey, change your tool after a certain amount of time, so that you got, hey, you don't go and break the tool and next off, cause downtime and all the rest of it. So we've got that, but we need to call that in our main program. So what we're going to do is call that basically just at this point, M98P8000. And then it's just going to run through that. Now you'll see if I reload this program up here, restart it, I've made a change to this program now. So it's actually updating that text file on my desktop. That's what those warnings are doing. And now we can go through the program right here. And I don't know about you guys, but I hate sitting and watching simulations run. I kind of just get a little bit impatient. So I just want to quickly update the stock at this point in time and not have to sit there waiting for an entire simulation to basically simulate, so I can just get and see what the end result looks like. So now we should be cutting. Yeah, go ahead.
So Daniel, I guess I have a problem with this, right? I mean, I just wrote all this inside the CAM system, right, and put all this together. I guess the good part is you didn't crash anything while you're playing it through here, right, and getting it going, and we didn't eat up the time on the controller, and we don't have programs everywhere. I guess my question is, with this, how do I know I'm running the right program? It's not going to come straight out of the CAM system now. How do I know you modified this?
Oh, well, we're going to store it all in the Vault, Tim. PDM, that's the solution for everything, right?
The SOLIDWORKS Vault?
We've got this. Yeah, the SOLIDWORKS Vault. So we've got this entire program here. You can see that it gives me an actual replication of the FNUC control. It gives me the £3000 warning here, change tool 4 because we hit that limit of 3 parts. But we've got this program right here. We've just made some changes to it. I got Control A, Control C, copy paste. We've got our Vault right here. Thanks for checking that program in, but I'm going to check that out now. So we've got our program stored in our PDM Vault, just like any other file that we have in SOLIDWORKS. This one's specifically to text files. And I'm just going to open that up and basically just go Control A, Control V, paste in my new program, hit save, and then check that back in. These programs can be associated to the revision, so you can actually associate them through the save as reference or copy as reference into the actual version of your SOLIDWORKS file, so the program rev matches SOLIDWORKS rev. So I just check in, I can put modified to add macro programming or whatever, D-line, date, whatever I want to do, just to kind of give it some information. So now that's stored in our Vault. It's saved, it's rev controlled, so that we know we can always go back to that original version if we wanted to. But now we've basically stored that in our system.
So
But
now at this point, do I just get my USB key and pull it off the vault and put it in?
USB key, no, I hate doing that because the Bill out on the shop floor loves to talk about his fishing trips, and I get to where I'm supposed to be going, completely forgot what I wanted to do, and I've already wasted half an hour.
So you know that Bill doesn't really go fishing, right? That's code word for I'm going to go look at car parts.
Good to know. I'm not going to use that one again in the future. No, I like to send my programs right from PDM. So we've got our PDM vault right here configured to use Predator to actually send this program direct from the vault itself through to the CNC. Now I've got Predator loaded up right here. This is my DNC control. So it's waiting on my communication to my VF3. I can right click on this particular text file, send it to the CNC, not having to walk across the shop floor with USB keys, get distracted on the way. It's actually going to be loaded into Predator. You can see this right here is being loaded right now into Predator and sent to the CNC. Conversely, I could also pull the programs from the control itself. I can actually have a short little program. I write the program number that I'm looking for, 01001 or whatever it is. It goes and looks on my server and then pulls it to the control itself. So I'm not walking across the shop floor, wasting time, getting distracted by X number of other people. So we're doing this right through PDM. We're sending the code through PDM using Predator and getting it sent over to the CNC. So
I'm thinking with all the stuff we've seen today, right? You're going to save quite a bit of time. So, not too long ago, we hooked up the machine data collection from Predator as well. So I
oh yeah,
sent you that link. Can you open that up live and we can take a look at that and then we can track kind of where we're at?
yeah, absolutely. We can see right in here. Basically, this is a live web page that we have running of all of our machines. We can take a look at the general overview of the dashboard, see which machines are cycling. So you can see right here, these machines are all cycling. You can see what program and part that they're running, who's running it. We can go back over to our main dashboard and see, hey, okay, these machines are down at the minute. Okay, looks like there's someone's getting machine alarms quite frequently. We need to figure out what's going on right there. We can even look at how productive we are. So we can look at a date range, and this could be either the guys on the shop floor, the machine shop manager, or it could be senior management taking an overview of what's going on. We can look at our overall efficiency, our overall equipment efficiency here at 66%. So we're only running jobs 51% of the time, but our setup time is pretty significant. It is at 10%, but our idle time is even more significant. We need to kind of see what's going on there. So let's take a look at maybe some more machine specific stuff. Let's look at the Duzan. Looks like the Duzan is actually pretty effective. We're using it 90% of the time. We're actually pretty efficient with that. Setup time is quite minimal.
Nice.
The DMG Mori right here. Ooh, looks like our idle time on our nice expensive Evo machine is pretty high. So we need to maybe check into that. Do you want to check in and see what the situation there is, Tim?
Yeah, I'm betting it's from the setup time, right? Like you just showed me how we can do the configurations inside the machine offline now. So I think we can eliminate that setup time inside there.
Yeah, for sure. Same thing with the VF2 that we're going to run. We've got a 57% efficiency right here. And now the bosses, I think, was saying that we're looking at getting a new machine, right?
Yeah,
What you
we
mentioned
are,
there?
but I'm wondering if we need a new machine or not based off what we just saw for the last little bit on all the tools we have to make that spindle run more efficiently and longer, right? But,
Yeah, exactly.
the bosses are not going to like to see it live. How are we going to present this to them?
Well, I've got one step ahead of you. I got a little PowerPoint. You know how those guys love PowerPoints. We've got our
Yes.
PowerPoint made here. We got a summary of just screenshots, quick and easy, quick and dirty. That's how we roll. Basically, a screenshot showing cycle times where you can see, okay, we've got the Duzan's pretty efficient, 91%. It's running efficiently. Maybe we need to add another lathe or something like that just to make that less stressed. But the Evo actually could be running efficiently, but we don't have enough jobs, or the guy's busy doing setup work or deburring stuff or something. We got to figure out an action plan there. So maybe we look at quoting a little bit more attractive pricing so we can get some more 5-axis work in, things like that. The
Hey,
VF2.
hey, Be careful.
Huh?
Them sales guys will be giving stuff away if you say they can do better pricing.
Oh yeah, I know what they're like. Yeah. Sorry, more efficient. Let's be more efficient with it, not be cheaper.
That's better.
So right here we've got our host VF2. It seems like from the operator he's doing a lot of deburring inspection, so maybe we need to crank up on maybe get some machine in to do some deburring or hire somebody. That robo drill doesn't look like it's being used, so we might need to be, I think it's waiting for repair, and maybe we just trade that and get a new machine and offset the cost basically. So summarize it, basically give it to the management, be more efficient with our 5-axis, solve some issues in our facility to kind of stop people deburring, or maybe we deburr on the machine with using some of the 2020 features for automatic curve feature selection and stuff like that. Maybe we need to hire someone and then we can get rid of our old equipment. So
sounds good.
But did you hear the guys in the fab shop? I think they're getting a robot, right?
Yeah, but if we get a robot, how are we going to communicate with it, right? I heard it has its own language.
Oh yeah, they're nothing like G-code. I don't want to start learning a whole new CAM system again. Let's see if we can do anything in CAMWORKS. So we've got our robot, we've got our diff housing here. Actually, we've got a nice Hawkridge Systems diff housing that we need to go and weld up. So we've got the guys in the fab shop sitting there cutting this stuff and manually welding all this stuff, when we could be welding it using CAMWORKS and using a robot. So we've got all of our multi-axis toolpath right here to kind of go and program the welder. I've got my machine simulator right here using Eureka. So I've got my machine definition over here is now my welding robot. My post is now an apt post. So this is an apt post that's specific to the welder. And obviously we can do robots that spray, we can do plasma controls and things like that. But right here, I can come in and output my code to Eureka, and we can actually post-process to the robot through Eureka, but doing our programming inside of this environment. So we've got our Eureka now configured to do robots. Now, what this is going to do is it's got our controls in here. We've got our full robot with an external axis in this case. So we've got a rotary table in this case that we've got our axles centered between, but we want to go and weld these up. So maybe it's all being tacked up already. I want it to just go and weld those flanges and start welding the edge flanges right there where the brake calipers mount. So you can see it's rotating. It's not only positioning the robot, but it's actually rotating the rotisserie as well and doing those welding. And then once this program has gone all the way through, we can output our code to the robot through Eureka. And using this gear icon at the top here will allow us to post-process to the move J, the move L commands that the robot understands. So we can also control the movements of the robot as well. We can control the approach to it. You can see here it's welding along that main seam there, comes up and over.
So
then we get into
So you've taken the code straight out of CAMWORKS. You put in just lines of code with a curve feature, however you did it. And then now you're putting that into the robot and making robot code.
Exactly, yeah. So, and we can
That's
actually
pretty cool.
change how that code looks by using the functions in Eureka and basically changing that. So now you'll see that it actually rolls down here, and we've just put in a new command there to change how the machine and the robot articulates, so it gets our weld done nicely and efficiently.
That's excellent.
So, and obviously we can simulate all of our high-end complex equipment and things like that as well. B-axis lathes, all the regular stuff that we're used to. So we'd just like to take a moment. That's the end of the main presentation. But we'd just like to take a moment to thank the sponsors, CAMWORKS and Predator, for actually sponsoring us for this session. If you do have any questions, please visit their booth anytime during the expo. They're in the main expo area. They'll also have a session tomorrow called a networking session that you'll see on the schedule. The one for Predator is at 1 p.m. So that's day 2 of the Design to Manufacture event on Wednesday, tomorrow. And 2 p.m. again, same day, but 2 p.m. an hour later is the CAMWORKS event. And we'd love to see you there. Tim's actually going to be there. So if you do have any questions, feel free to join Tim. It's going to be a question and answer session with a bunch of panelists there. So if you do have any further questions outside of this, just get in touch with us through the normal routes. You can see the information up there.